Section 9.2 is the law of sines. We're able to solve this triangle. This is not a right triangle. This could be lots of different angles. It could be acute or it could be an obtuse triangle, but we can solve it using what's called the law of sines. Remember, the big letter of the alphabets are for the angles and the small letters are for the sides, and then they're opposite of each other, like so. So the law of sines is right here. It says the sine of A divided by the sine of the angle A divided by A is equal to the sine of B divided by little b, and then the sine of C divided by little c. So you can use this ratio, so you can put the A's together, or you could use this ratio here. You could put the B and the C together, or you could put the A and the C together. So it's all, those are all the different combinations of that. There's different cases of things that you know. Sometimes you know the two angles and then the side in between. Sometimes you know the angle or the side and the two angles. Sometimes you know the angle and the side, and then sometimes you know the side angle side, and then sometimes you know all the sides. So we can do different things. We got to watch out for this one right here, the side angle one, and I'll show you why here in a minute. So let's go ahead and jump in and do the exemplary problem. Number 9. So number 9, we're to solve the triangle, which means you're supposed to find all the angles and all the sides. So here's number 9, the pencil. All right. So we know this angle right here because we can add all of these together, can't we? So we got that plus that would be 140. So then this would be an angle of 40 degrees. So that's pretty straightforward, isn't it? And that's 5. So what we do here is we just say sine of 95 goes with 5. So sine of 95 degrees goes with 5. So this is to this. And then we can do sine of 45 goes with b. So sine of 45 degrees goes with b. So that's a proportion. So this is to this as that is to that. And then we put the sine on the angles. So how do we solve a proportion? Well, we're going to cross multiply these and then divide by this. So basically it's sine of 95 degrees times b, right, would be equal to this times this, which is 5 sine of 45 degrees. All right. Then we divide over the sine of 95 degrees. Divide by sine of 95 degrees. That cancels out. That's what b is. So we type this into the calculator, wherever I set my calculator. Oh, here's Mr. Calculator. Oops. Clear. I was looking for something earlier. There we go. So it's 5 sine 45, close the parentheses, divided by sine of 95. So that's 3.5. 3.55 is b. So up here, b is 3.55. All right, now we can go after a. I know that that's 40 degrees, so I can use that. So we get sine of 40 degrees over a is equal to, and then I could just use this one again, sine of 95 degrees over 5. So I already have that set up, don't I? So that's a ratio that I can use. So this time I'm doing 40 goes with the a, so sine 40 over a, and sine 95 goes with 5. All right, so it's going to be the same setup. It's this times this divided by this. So a is equal to 5 sine 40 divided by sine of 95. Now I'm not going to let a good typing of the calculator go to waste. I'm going to go up in here, and all I have to do is change this to, oops, hit enter, and then go ahead and change that to 40 degrees. So it's 5 sine 40 degrees over sine 95. 3.23. 3.23. And there we have solved the triangle. All right, here's where we get ourselves into trouble with this. And it has to do with inverse sine. Remember, inverse sine only tells me answers between negative pi over 2 and pi over 2, between negative 90 degrees and positive 90 degrees. So when I do inverse sine of this angle, it's going to give me the wrong angle because that's an obtuse angle. So we have to figure out what that angle really is. We have to use our concepts from the past chapters. So this is where the problem where you got to watch out for. So you have to make sure that it makes sense with the answer. So we have sine of 30 degrees compared to 11, right? So that with that, and then sine of theta, and then 21. So it's this times this divided by this. So we have 21 sine 30 degrees. So it's this times this divided by that. 11 would be sine of theta. So now to get the answer to this, we have to do inverse sine of each side of the equation. So it's inverse sine of 21 sine 30 degrees over 11. And that's what theta should be. But it's not going to be that answer because of the fact that that's an obtuse angle, and the inverse sine is only going to give me an acute angle. So I have to figure out what angle I'm really talking about there. So it's if we understand the concepts from before, it's not too bad. Okay, so we're going to do inverse sine. And by the way, I'm all in degrees with this. So it's inverse sine of 21 sine 30 degrees divided by 11. 72 degrees. So theta is equal to 72.6586 degrees. All right, so that's 4 decimal places. Now, if we're thinking about the sine curve, right? So here's the sine curve. There's 90 degrees. So 72 degrees is going to be right in here, right? So the other place where it's going to be equal is right over here, the same distance from 90. So this is like 72 degrees, right? The same distance over here would be 18 past. So it'd be like 108 degrees. I'm going to get more accurate than that. So those are going to have the same answer. So the sine of 72 is the same as the sine of 108. So if I do sine of 72 degrees, it's the same thing as the sine of 108. They're the same answer. Okay, it's just in the other quadrant. It's the obtuse angle. Another way to look at it is if you were drawing your triangle, right? All students take all students take calculus, right? So if I draw a 72-degree angle like this, and then what would be the one equivalent to it? Well, it's got to be the same amount of space over here, right? So from there to there, right, and there to there has to be the same amount of angle. So it's 18 degrees here and 18 degrees there. So we go, that's going to be the same answer. Basically, you know, if you have the sine of 30 degrees, right, that's the same as the sine of 150. So that plus that has to be 180. Those are the same answers. So that's another way to look at it. so I'm going to go back to my very accurate answer here. And so I'm going to go up, 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 up. Okay, so I'm bringing that down, answer. So there's the answer. Okay, now I need to do 90 degrees minus this answer. Okay, so it's not 18 degrees, it's 17.3 degrees. Okay, well that takes me up to 90, and then I need to add that in again. So it means I have to double this. So times 2, 34 degrees, and I'm going to add that to this answer here, plus the last answer. So it's 107.3. Okay, so like I was talking about 8 with like 108. I mean, if you want to round to make it easier on yourself, that's basically what it is. So this angle is not 72 degrees, 72 degrees and change. This angle right here is 107.34 degrees. So that's where you get yourself into trouble when you're doing inverse sine. Inverse sine only gives you answers between negative 90 degrees and positive 90 degrees. We talked about that a whole bunch when we were all together. So you got to watch out for that. You got to make sure that your angle matches the picture. If you look in the book at example, example 3, 4, 5. So example 3, when they do this, there's no answer for it. It doesn't work. There's no answer. There's no solution. Example 4 in the book, there's one solution, so you don't have to worry about that. But then example 5 has 2 solutions to it, and it's this thing that I'm talking about right here. If you wanted it to be 72 degrees, what would happen is, see this 11 degrees here, this 11 measurement would flip in here, like this. So this side can be here or there. Then it would be 72 degrees in there. So it does a flippy thing back and forth. So if I wanted to know, but then that wouldn't be 21 anymore. So it just, you got to be careful with this when you have these obtuse angles. All right, let's do another question together. All right, what is this problem here about? Well, it's basically you don't get a picture, but you have to think of this picture. Just remember that these are opposite of each other, the angles and the sides with the capital letters and the smaller letters. It's a standard for geometry. It's like that in all geometry, trig parts. Okay, here's the exemplary problem. Basically, these two angles here are 40 degrees. So that's A, and then that's B, 40 degrees. So A and B are 40 degrees, and then that means that C up here would be 100 degrees. All right, and then that's angle C, so this would be 2 down here. So we're supposed to figure out what A and B are. So this is angle B, right? So B goes with little b, that's 40 degrees. And there's angle A, right? And it goes with little a, and then there's angle C, right? And I just did 40 plus 100, right, to make the 180. So I got to figure out the two sides. So really this is just one problem because this is an isosceles, right? It's an isosceles triangle. The two sides, A and B, are both the same because the angles are the same there. So here we go. Sine, you just ratio these. Sine of 100 degrees over 2 is equal to, and it doesn't matter, you do A or B. So sine of 40 degrees over A or B. So it's going to be this times this divided by this. So A is equal to 2 sine 40 degrees divided by sine of 100 degrees. Just type that into the calculator and you get your answer. So I've already typed it into the calculator and you get 1.31. So A is 1.31 and so is B, 1.31. So they're the same because it's isosceles. All right, here's number 25. It's the next exemplary problem. So this is 50 degrees. I'm going to call this A. This is 50 degrees. So little a is 3. So we put a 3 over here. All right, B, we don't know what B is, so capital B is unknown. But we know the little b is 2. Capital C is unknown, and then little c is unknown. So we got to find all these. Now, we're supposed to determine whether the result is 1 triangle, 2 triangles, or you can't do it at all. So here we go. We can go ahead and get angle B right now. So sine of 50 degrees over the 3 is equal to the sine of B over 2. So it's this times this divided by this, inverse sine. So it's this times this divided by this. So sine of B is equal to 2 sine 50 degrees over 3. This times this divided by that. So we type that in the calculator and then do inverse sine. So it's 2 sine 50 degrees, class is over, divided by 3, and then we're going to do inverse sine of that. So inverse sine, second answer. Okay, 30.7 degrees. So B is 30.7 degrees. So 30.7 degrees. Now, what other angle associated with that would be the same? Well, it would be the one that would make 180, right? So if we do 180 minus the last answer, it would be 149.3. So could this angle right here be 149.3? Well, the answer is no, because if you put 50 and 149.3 together, then that's over 180 degrees. So we don't have to worry about the weird case on this one. But they have the same angle. So to prove, or same sine ratio, to prove that to you again, so it's sine of 30.7. Whoops, I hit cosine. Sine of 30.7 and sine of 149.3 have the same ratio. So it has to do with the fact that inverse sine can only give me the angles between negative 90 and positive 90. So we're to have positive angles. So just between 0 and 90 is what we're looking for. So the other angle would be the supplement would have the same sine. Well, it can't be that angle because then I'd have more degrees than there would be in the whole triangle, right? Okay. So now I know this is 30.7. I can find that angle right there. So 180 minus 30.7 minus 50 would be 99.3. So this angle is 99.3 degrees. All right, so now I can find this sine right here. So we just ratio this. I already have, this one's already set up, so sine of 50 degrees over 3 is the same thing as the sine of 99.3 degrees over C. So then it's going to be this times this divided by that to solve the proportion. So it's 3 sine 99.3, close the parentheses, divided by sine 50. So 3.86. So this side right here is 3.86. So those are the 3 angles and the 3 sides. Okay, the next exemplary problem is number 31. All right, question number 31. So I'm going to draw the triangle like this and label it as best I can. This is number 31. It's the other exemplary problem. So it says angle B is 20 degrees, so that looks like 20 degrees. So I'm going to call that angle B 20 degrees. The side opposite is 4. So little b is 4. That'd be over here. And then C is 6. We'll call that capital C. We'll call this capital A because that's the other one missing. So there's little a. So I need to solve for the angle and this angle, and then the side. So I know two sides. So I'm missing one side and then the two angles. So let's go after angle C first because it has the 6 opposite. I can't use A at all because there's nothing there to use. Sine B would be sine of 20 over B, which would be 4, is equal to, now C, sine of C over 6. So it's this times this divided by this, and then inverse sine. So on the calculator, it's this times this divided by this. So it's sine of 20 divided by, times 6, this times this divided by 4. And then we got to do inverse sine. So inverse sine, second answer. So it's 30.9 degrees. So C is 30.9 degrees. 30.9 degrees. Now, the supplement would also be the correct inverse sine. So if I do 180 minus the last answer, oh, I didn't do 180. Okay. So I'm going to do 180, not 108, minus the last answer. I got 149.1. So could this be a possible angle? 149.1. It would be a possible angle because if this was 20 and that was 149, see there's a little bit of room left for angle A. So it could be either one of these answers. So there's two answers for this. So what I'm telling you is the sine of this angle is the same as the sine of that angle because inverse sine only gives me that acute angle. It won't give me the obtuse angle. But this obtuse angle would work because if we do this plus 20, then you can get that answer down here. So to prove this to you, let's go ahead here to the calculator and show you that these have the same sign. So sine of 30.9, close the parentheses, is the same as the sine of 149.1. So they give you the exact same answer. And there's room. The last problem there wasn't room because it would have been over 180 degrees. Okay, so now this plus this, so I'm going to do two things here. I'm going to do an orange angle and then I'm going to do a green angle just to kind of sort this out with color. So the picture's not going to be right, but the angles will be right. So I'm going to do 20, so I'm going to do 180. There we go, 180 minus the 20 minus 30.9. Okay, so it's 129.1. So that could be this angle right here. 129.1. So if you put the original angle and those two angles together, that makes 180. Okay, now I'm going to do this one and the green one. So 180 minus 20 minus the 149.1. So it's 10.9 degrees. So this angle right here could be 10.9 degrees as well. These are all degrees. That's a degrees too. Okay, so angle A could be either one of those, angle C could be either one of those, and we know that that's right. So the 20 goes with the two greens, or the 20 goes with the two oranges. So there's two different triangles that could work here. Okay, so now we have to do A twice. We have to solve for A twice because it could be two different lengths. It could be a shorter length or a longer length, depending upon if it's the little angle or the big angle. So I'm gonna use sine 20 degrees over 4 because that's the good one, and then I'll do sine of 129.1 degrees over A, and then to solve for the other version of A, I'd do sine of 20 degrees over 4 is equal to, now I'm going to do the 10, sine of 10.9 degrees over A. So now I have to solve for A twice because there's two lengths that work for this. All right. So basically, I don't have to do inverse sine on these. I just do this times this divided by this times this divided by that to solve the proportion. That's why you get the farther you go in math, you just get incredibly good at proportions, because we're doing proportions with trigonometry. When you're in Algebra 1, you're like, oh, what's a proportion? How do I solve this? But then in trig, you're like always doing proportions because, you know, it's trigonometry and ratios and all that kind of stuff, and fractions and et cetera, et cetera. So sine of 129 divided by 1, or times 0.1, sorry, and then times 4, and then divided by sine of 20, and 907. So 907 is one of the answers. Actually, you could round it to 8. Okay, the other answer for A would be solving the second one, which would be this times this divided by 20. So really, I can just go up in here and just change the angle, because it's this times 4 and then still dividing. So I just go in there, change that to 10.9, delete out the 1, times the 4, yes, 2.21. So those are the other lengths of the sides. So let's go ahead and colorize that. So this big angle would go with the longer side, right? So if we have 20 degrees, this angle, it'd be that length over there. And then if it's the shorter angle, then it'd be go to the shorter side right there. So there's two triangles that are happening here in number 31. Now on to the story problems. But before we go on to the story problems, let's go back and look at these problems here. To build your confidence, you need to do a couple of these, because the picture's already there and there's just one solution for these. Okay, so go back and try number 11 and look at the answer in the back of the book to make sure you have it right. And then why don't you try number 15 and then check the answer in the back of the book. So you're just doing sine of this over this. I mean, you know that angle right away, right? So that has to be 40, because it's 40, 40, 100. All right. And then you just do the sine ratios. You're going to get your answers real easy. This one here, you can find that angle really quickly, and then you just start doing the ratios. So these will build your confidence, these two. Then pick a couple out of here to do, and here you have to just make the picture. So I would just pick any. We did 23 together, so I'd pick any other two. Like just do, you know, like 19 and 21, and then see if you can get the right answer. So they gave us two angles and a side. So you know one of the angles already, so you just got to figure out the sides. So you don't have to worry about those extra cases, because you're not doing inverse sine. You're only doing the sine of the angles you know. So there's no inverse sine on this. That's why we don't have to worry about that. Then these are the harder ones. Now it says in the directions here that one triangle, two angles, or no triangles. So there's actually the ones that have no triangles. Like if you try number 29, there's no solution to that. There's no triangle that can be created by that. So that would be an interesting for you to try to figure out why there's none. 33 is the same way. You cannot. There's no way to make a triangle out of that. When you do inverse sine, it'll error. There's no answer to that one. There's no answer to 32. And there's no answer to 34. So all four of those have no solutions. Now the other ones here are going to have one triangle or two triangles. So we demonstrated 25, which was one triangle, and then 31, which is two triangles. So why don't you try like 27 and 35, and then go ahead and look at 33. Why is that not going to have a triangle? That'd be interesting to look at. Okay, now the story problems. So this is what would be known as an indirect measurement. We're not going to actually measure the length down the ski slope here. We're going to do it indirectly. So we measured the angle of incline is 25 degrees. We step back 1,000 feet, and then we measure the incline angle again, 15 degrees. So we know this is 25. Then over here we would have the supplementary angle. So that would be 155 degrees, correct? So we, my brain's melting. So it's 180 minus 25 is 155 degrees. Okay, so this is 155 degrees right here. So if this is 155 degrees and that's 15 degrees, we know this angle up here, which would be important because it's opposite of the 1,000. We need that for our law. We need that for our law of sines. We need to know that the opposite angle there. So this plus this, that would be 170, correct? Plus 15, yep, 170. So we're missing 10 degrees right there. Okay, then we can find out what x is, which is the length of that PQ situation. So we just have it set up here, sine of 10 degrees over 1,000 feet. So this goes with this, right? This goes with that. And then 15 degrees goes with the unknown side, the P and the Q. Sine 15 degrees and then x. So it's this times this divided by that. Should give us the length of that. And it looks like it's going to be more than 1,000 feet. So again, this is an indirect measurement. So it's sine 15 times 1,000. Oops, I need to close the parentheses. Times 1,000. And then, so it's this times this divided by this, divided by sine of 10 degrees. And 1490. So x is 1490.5 feet. So that's going to be the run of the ski slope, 1490.5 feet. They rounded to 2 decimal places in the book. They did 4.8. All right, 43 is a good problem because it's going to involve the last section and this section put together, so we can combine these two ideas together. So again, this is another example of indirect measurement. We need to know how tall the tree is. All right, here we go. So we take a measurement of the tree. So here's the tree. I'm going to call this y. The tree is y tall. And we take one measurement out at a 30 degree angle, and then we go back 40 feet and then we take another measurement to the top of the tree, and it is 20 degrees. All right, so for some reason we don't know this distance right here. So we could use right triangle trigonometry if we knew the distance from here to here, but for some reason we can't get there. We don't know that distance, but we go here's 30 degrees, go back, then there's 20 degrees. There's 40 right there. All right, so this is 30. That means this is 150 degrees. So that makes the 180. So 20 and 150 is 170. So that means this angle up here is 10, which I need to know. All right, so now we can figure out x, because we got 10 goes with the 40 and 20 goes with the x, that distance there. That's the law of sines. So sine of 10 degrees over 40 is equal to, so that goes with that, and then the 20 goes with the x. Sine of 20 degrees goes with x. So it's this times this divided by that. So we do 40 times sine 20, close the parentheses, divided by sine of 10. 78. So that means this length here is 78 feet. All right, now this is just a right triangle, 30 degrees. The distance from here to here is 78. So then this is now a SOHCAHTOA problem. So the sine of 30 degrees, it would be the height of the tree, y, divided by 78. So now I'm going to multiply this over to get y by itself. So it's 78 sine 30 degrees is y, the height of the tree. Sine of 30 is a half, so basically I'm just taking a half of this. So we're going to multiply times 0.5, because that's a half times this answer that's already sitting on the calculator. So there's the height of the tree, 39 feet. So 39 feet. So when we make it fall over, then we can figure out if it's going to hit the fence or not. Okay, this would be a good one for you to try. Number 41, triangular plot of land. I'm going to help you draw the picture, and then you can try it and make sure you get the right answer. So the triangular plot of land has one side along a straight road measuring 200 feet. So here's the straight road, 200 feet. I made my road north and south for some reason. One side makes a 50-degree angle with the road. So that makes a 50-degree angle with the road. And the third side makes a 43-degree angle with the road. 43 degrees with the road. How long are the other two sides? So you just have to find, I guess we could call this C, and you're just looking for A and B. So that's pretty straightforward. So try that one, see if you can come up with the answers. We know the angle automatically because the three angles make 180. Then you got sine of this over this, and then sine of this over that, and then do your ratios and find the sides. So give that one a try. Make sure you can do that one. All right, here's the last one we're going to do in this section. It's the exemplary problem. I want you to do it with me, and well, actually you're going to do the whole thing I want you to do the whole thing with yourself. I'm going to give you some guidance, and then you can check your answer. So the first thing is you want to read the question and then draw the picture. All right, so here's what you should have drawn. So you pause the video and see if you got it right. Okay, so we have Station Baker is here in the north, and then the Coast Guard Able, is to the south, because it says it's 150 miles south of it. Not feet, miles, 150 miles. Okay, so that's 150 miles. Then if we're looking to the ship, there's a ship out here sending a distress signal. So it tells us that going out to the ship, it makes a 55-degree angle from the Coast Guard station, and from Station Baker, it makes a 60-degree angle. So it wants to know the distance from each one of those ships. So we could call this A, and we could call this B, call this angle C right here, side C. And we gotta find these. Okay, so it's 150 miles there. It makes a 55-degree angle this way. So we automatically know what this is. Using the sine ratios, we can find that. These two distances are about the same. So if you go in 200 miles per hour, so distance is equal to rate times time. So we know the rate and we know the distance. You would divide and you can get the time to do how long it would take a helicopter to go out there and rescue the ship. So try that one, and you should be good on this section. There's the Leaning Tower Pisa problem in here. That's doable. You're welcome to do extra problems and checking your work as you go. So here's the Leaning Tower Pisa one. I got so many papers here. I found it sorting through. Basically, you're just looking for the angle at which it's leaning, and then it wants to find the perpendicular distance. So the perpendicular distance would be from here straight down, which would make a right angle. But that's okay because you know this side and now you know this angle. So you can use right triangle trigonometry to figure out the new height of it, or from that point down, how tall it actually is now. So that's a good problem, combining the two things together where you're doing the law of sines and then you're doing a SOHCAHTOA situation to find that vertical height. So that would be a good one to try as well. But the picture's already drawn for you, so it's not too bad. If you want to, you could find that angle up there really easily, right? So this goes with this, that angle up there goes with this. That would give you this angle, and then you know two angles, you get the third angle, and that's what they want right there. Is the leaning angle, I believe, RPQ. Once you have that leaning angle, then you can do right triangle trig to figure out that perpendicular distance right there. So give that one a try as well.